Well, welcome everybody. Thank you for joining us this evening. It's definitely way better temperature-wise, and I've been enjoying the outside. So tonight we have Rob Lehmert who's a principal carbon negativity consultant, and joined with Marshall Webb, who's the carbon drawdown coordinator at Shelburne Farms. We're going to be talking about biochar, their uses at Shelburne Farms, how it's made, how it's applied, and the future uses in biochar and beyond. So thank you very much again for joining us, and I'll turn it over to Rob and Marshall.
Thank you and good evening, everybody. Let me get my screen going here. Here we go. Okay. Yeah. Hi, I'm Rob Lehmert. Thanks for coming out this evening. It's a beautiful night. There's probably a bunch of things you could have done, but here you are, and we really appreciate it. I think we have an interesting story to tell. Marshall will be talking about how since 11, 12 years ago, he's been working to draw down carbon emissions. We're all concerned very much with climate change. That's really my first approach to this particular topic is due to the fact that it is one of the only practical ways to take anthropogenic carbon dioxide, that is carbon dioxide that was produced by photosynthesis, take it out of the atmosphere, because I am personally very concerned that warming is proceeding to accelerate, and that we run a risk of what's known as overshoot, and may pass 1.5 degrees over pre-industrial temperatures very quickly, and that's when things are going to get hairy. So anything we can do now to pull carbon out of the atmosphere is very important to me, and I think very important to all the people living on Earth. And I happened to discover biochar about 5 years ago. It is an ancient thing. It's referred to in writings of ancient Romans and all through the 18th and 19th century. But it's really only about 10 to 15 years ago that serious research took place on biochar. And I think it was stimulated by a realization that it could play a very important role in controlling greenhouse gas emissions. And what was discovered was there are a multitude of other uses for biochar, which make it extremely useful and extremely desirable. So I'm going to give you usually when I attend sessions on biochar, they can last 4, 5, 6 days. Both Marshall and I have done extensive traveling and attended extensive seminars on the subject, but we don't have that time tonight. We have a very limited time, so I'm going to give you the bare bones. All right, so what are we talking about here? We're talking about a substance which is a concentrated organic carbon resulting from baking biomass under low to zero oxygen conditions. So let's parse that a little bit. We're talking basically about the Germans call it biocoal. It is not quite coal, but it is organic carbon. It's almost pure carbon, and it results basically, if you can just imagine baking bread. And you put a loaf of bread in your oven to bake. And if it's properly set, you end up with a lovely smell in your kitchen, which is a thermochemical conversion of that yeast and flour and the other good things. It's thermochemical conversion into a finished loaf of bread. But if you turn the temperature up to, let's say, 600 degrees Fahrenheit, or maybe even 1200 degrees Fahrenheit, and did nothing else, just little oxygen in there, you're going to have a fire, and it's going to combust. And combustion requires oxygen. Now, what we do in making biochar is we remove the oxygen. And without oxygen, the heat comes from an indirect source. So essentially, think of it as though we are baking a piece of wood, and the volatile gases from the wood are being expelled, taken someplace else, and they burn outside of the presence of the biomass. And that heat is then applied indirectly to create the biochar. So that way we end up with carbon and not ash. Otherwise, if there was oxygen present, it would be ash. We're having a little trouble advancing here. There we go. All right. So when we are done, depending on what we are carbonizing, we will end up with a substance which is anywhere between 40 and 95% pure carbon. Hardwood, which is the thing that we work with most commonly, will be close to the 90% level. There's some trace elements in there, but by and large, it's carbon. Now, this is unique carbon. It's different from the carbon that we see in soils and soil organic carbon, in that it was made in without the presence of oxygen. And the fact that there is no oxygen within the carbon itself makes it extremely stable, makes it basically immune from attack from microbes. And that is what, I mean, if we go out to the forest and look at the debris that's in the forest that constitutes soil organic carbon, that's all subject to attack by insects and microbes, and it gets wet, funguses, lichen, whatever. And after a period of 10 or 20 years, it's basically been decomposed, and virtually all of it will end up back in the atmosphere. And that's the carbon cycle. That's the natural way things are. And before man started digging coal out of the earth, that was perfectly fine. But it's I believe a bit of an exaggeration to think of forest carbon as anything more than a short-term carbon sequestration. It is a carbon sequestration, but it is a short-term one. And it relies on the replacement of live trees, growing trees that die with new trees. And there are places on Earth right now where forests are actually emitting carbon rather than storing it if there's been big die-off. But here we're dealing with something which just it's been created in such a way that it's not really subject to this. Now, you'll notice over here to the right, I've got it says C tiny URL. And I will provide you a link to a document in each of the things that I talk about tonight that explains what I've just written here in some additional detail that we don't have time to go over tonight, but you may find it very interesting. Now, so we end up with pure carbon. It's actually locked up C6, six atoms of carbon, and so when it sequesters carbon, we're not sequestering CO2, but rather something with a heavier molar weight. And when we talk about a ton of biochar, typically it equates to 3 units of CO2 equivalent, which, if you think about it, a gallon of gasoline, you know, depending on what kind of fuel we're talking about here, but a gallon of gasoline is about 22 pounds of CO2 in it, CO2e. So 22 pounds is 10 kilos. And if we have a ton of, if we take that 10 kilos and not do 100, but let's say 1,000 kilos of CO2e is equivalent to 3,000 gallons of gasoline. That's what we would be sequestering with 1 ton of biochar. Now, it's very powerful, and as a carbon sequester, it doesn't take a whole lot of it to start to add up. So the thing about biochar is, as carbon, it has some very unique characteristics, and carbon is an extremely abundant element. And it's, it's been referred to as God's element. Shows up in all life. We're all, made of stardust. But what we end up here with, because of the processing, is what charcoal looks like. But when you get real close, you will notice that it is all a series of pits and tubes, and it has a massive interior surface. In other words, the interior surface, because of how porous it is much larger than its surface area, and that is a place. Think of it as a coral reef for microbes in agricultural soils. We never apply biochar without some type of inoculation to give it life. It's not fertilizer, it's structure. And the microbiota are very much attracted to inhabiting the pits and pores of biochar. They like it because it typically sequesters moisture. They like it because there's a slight electrical charge to it. And because of those two characteristics, the fact that it has that electrical charge makes it extremely adaptable for all sorts of other uses, but it's terrific with compost. I would highly recommend it. If you're going to apply it thin, and apply it in connection with something that's alive, because biochar is not alive, it's structure. Now, it is a very valuable tool for controlling and repurposing nitrogen, phosphorus, and other materials, which makes it extremely useful in an agricultural context. And Marshall's going to address that more. But specifically, I think that manure lagoons are just a terrific idea for any dairy or anyone that's raising swine, chickens, any animals. If you're collecting manure, covering that is a great way to avoid very significant air and water contamination, and the air pollution that's coming off that, in addition to being quite odoriferous. And Suzanne, I think that was really the origin of your invitation to me, was the problems with spreading of manure on fields, and the problems that caused in some of the towns. But
I didn't.
we're going to elaborate on this particular point as we go through the questions and answers. But this is a primary use for agriculture. Another primary use is the use of biochar as a feed additive. There was some amusement a couple of months ago when it was when the news article came out that they were able to reduce the enteric emissions of cattle using seaweed. And it was a real novelty. I mean, everybody's very concerned. I think there are people out there who are very much opposed to continuing to raise farm animals in the future because of the contribution of methane to the atmosphere. And we've known for a long time, and it's very heavily documented, that the use of biochar, when added to the feed of farm animals, has a very beneficial effect, not just in reducing enteric emissions, but also improving their health, and also improving the weight gain, their efficiency. There is very often people are talking about there should be a price on carbon. And I agree, there should be a price on carbon, but in fact, there is a price on carbon already in existence, and it's a pretty hefty price. You may be familiar with the term carbon offset. What we're doing with biochar and with respect to carbon sequester is not an offset, but rather a removal of carbon from the atmosphere via photosynthesis and processing. And that is a very valuable service. I think that you may be very surprised at how much people will pay to obtain a certificate, a certified removal of carbon dioxide from the atmosphere. And this is a real issue right now with many corporations. Stockholders are really putting the feet to the fire of management to make them reduce their emissions. And there are some businesses that cannot reduce their emissions quickly, like airliners and shipping industry. Microsoft, for example, any number of industries have decided that they want to become carbon neutral from the time of their inception. And what we're doing here with biochar is a very popular way to use carbon removal through biochar to offset emissions. Finally, I just wanted to mention that biochar has been listed by, well, it was mentioned by the IPCC in the context of climate change and the Paris Accords. It's on the international radar. I talk with people from all over the world on sort of a daily basis. Biochar is extremely popular all over the world. Very active in Australia, very active in Europe, very active in Asia. We have been a little slow in the United States to adopt it. There's been a lot of resistance because it functions so well as a substitute for artificial fertilizer. There has been some resistance from the commercial fertilizer industry to adopting practices that upcycle manure and add carbon to it to replace artificial soils. But now we have the NRCS has come out with a soil conservation practice, which offers very substantial reimbursement for farmers who apply compost, biochar, or a mix of biochar and compost to their fields. And I expect that is going to become increasingly popular. If you work with NRCS, be sure and keep an eye on it when they announce the 2022 awards, but they were very substantial. It would certainly cover the cost of putting biochar up to 4 acres, 4 tons an acre. It's a very generous program. Now, that said, I want to amplify a few points that I just went through really quickly. So what you're looking at is a cross section of biochar with an electron microscope. These are measured in units of 1/1,000,000th of a meter, so they're really tiny. And essentially, what you're looking at is what's left of the lignin of a piece of wood, and you can see in there that there are lots and lots of holes and pits, and each one of those provides habitat. In the soils, it provides habitat. It provides a space for example, manure to adhere to the surface of all those walls. It offers an opportunity for specialized pre-treatments of biochar that are meant to do special jobs like pull arsenic out of the soils. I mean, we know how to do these things. We can pre-treat them with other compounds before we create the biochar and make them do all sorts of interesting things. But that's pure carbon that you're looking at, and it is not permeable by water. That's why it has such a long residence in the soils. Now, this is a friend of mine in Australia. He lives in the desert in Australia, in the northern part of the continent, and he makes his own. He's in the biochar business, but he likes to grow strawberries directly in. I would never advise that kind of concentration of biochar. Typically, I mean, we apply it in thin layers and work it in more to what you would see in that upper right-hand corner. That represents an application of biochar with some compost into a soil, and that's about the consistency. But you can see that strawberry plant is not shy about the fact that it's growing in biochar, and that's a very good sign. Now, in the bottom right-hand corner, that is a photograph of a lump of biochar, which has been colonized by a mushroom, and it's sitting in a pile of manure. Now, manure, as we know, has got all kinds of nutrients in it, and that fungus has its choice of where to put its roots. It probably likes the moisture that's stored inside of the biochar. It's reliable. It absorbs moisture when it's wet, and it releases it when it's dry. Makes it an ideal habitat. I think that shows this. Here, I wanted to mention that the biochar is made through a process called pyrolysis. So that's separation by fire. And what we're accomplishing here, this is a very inexpensive kiln called a Contiki, and it's manufactured for use on a farm. This particular model. We have much more sophisticated models, but this is very basic and it works. And the thing about using a Contiki cone like this, all biochar is lit from the top and burns down. So, you know, when we start campfires or start a fire in our fireplace, we start at the bottom and let the flames go up, and that creates smoke. So by lighting it on the top, particulate matter goes through the flames and is burned, and that way we don't get the smoke that we would get in other ways. But this is a portable kiln. It's got a little heat shield around it, which is really intended to create an updraft. So there is a draft coming from underneath and blowing up and providing a good blast of oxygen to the top, which is where all the combustion is handling. Now, after an hour or so, you end up with a pile of biochar, very little ash. We are starving the fire of oxygen in order to end up with the charcoal rather than ash. Now, I did want to concentrate. I know Marshall's getting ready. We're going to turn it over to him in just a minute or so. But I believe strongly that manure lagoons should be covered. Cover them any way you want. But I strongly believe that if the amount of methane, ammonia, hydrogen sulfide, and the various gases that come off a manure lagoon were understood, not to mention the occasional flooding that we get, and overflow that we get in the wintertime, that we would want to immobilize a manure lagoon using biochar. And we would use biochar because it captures the nitrogen and hydrogen that is absorbed onto all of those little pores that we saw in the early photograph, and between that and the phosphorus which is absorbed, we end up with a slow release fertilizer that can be directly applied to the fields and completely displace commercial fertilizer. Unfortunately, manure lagoons are treated like open sewers, and it need not be. It's a situation where something of great value is not being fully utilized. With that, I want to thank you, and I'm going to turn it over to Marshall now. This is my contact information. I've thrown a lot at you today. I apologize for the fire hose. of information. I'm happy to come back another time and talk about a different aspect of this. I'm also happy to take your individual questions either by email or by phone. And I will be providing links to source material that substantiates the statements that I've made tonight. And I hope you've enjoyed what I've had to say. Thank you.
So I am Marshall Webb. Good evening, everybody. I'm Carbon Drawdown Coordinator at Shelburne Farms. And actually, I've never heard that job title in any other organization. So I feel very, very blessed and privileged to have that title. I'm not a scientist, and I'm not really a biochar expert, although I've learned a lot from reading about it over the last 12 years. One thing I'm sure of is that biochar is going to play a key part in reaching Shelburne Farms' goal of being carbon negative by 2028, to reach a point now known as drawdown. Drawdown is defined in the Drawdown Review published in December of 2020 by drawdown.org as the future point in time when levels of greenhouse gases in the atmosphere stop climbing and start to steadily decline. So how is biochar going to help Shelburne Farms get to drawdown? Because it has a huge impact in 3 different areas: energy, agriculture, and the environment. I'll tell you about those impacts after I give you a super short history of the farm. Today, Shelburne Farms is a nonprofit environmental education organization and working farm. Originally, it was established as a grand agricultural estate by my great-grandparents in the 1880s and 90s. They purchased 32 farms, totaling 3,800 acres on the shores of Lake Champlain. They hired Frederick Law Olmsted to design the landscape and an architect named Robert Robertson to build 4 magnificent barns, and the main house too. Around the year 2000, the significance of the property was recognized as a National Historic Landmark. The farm barn pictured here houses our education center, administration offices, and cheese making. In the near future, I hope to heat this barn with a biochar reactor. More about that later. Every day we haul milk from our brown Swiss cows at the dairy to the farm barn to make cheese. This enterprise, along with operating the former main house as an inn, which you can see in the background there, and combined with annual fundraising, provide the bulk of the financial support for the organization. I first got interested in biochar as a way to filter phosphorus and E. coli out of water. From several years of testing the water in ditches feeding the lake, and you can see one sort of going diagonally through the middle of the photo here, I knew that when we had rainfall greater than about 1 inch, that elevated levels of phosphorus and E. coli were in the water heading to the lake. The natural filtration of the wetlands at the ends of the ditches reduced the levels, but they were still higher than state recommendations. In 2010, I hired a fellow named Bob Wells of New England Biochar, based on Cape Cod, to make 2,000 pounds of biochar out of sawmill waste with his mobile retort. This is basically just a metal box with ductwork around it that allows the half quart of wood inside to be heated up to 900 degrees centigrade. As I watched this operation, I wondered about capturing the waste heat and using it to heat the farm barn. Now, 11 years later, there are several biochar reactors that one can purchase to do just that. The biochar that came out of the retort was pretty chunky. We stomped on it for a bit to break it down some and put it into a wooden structure with fabric sides reinforced with chicken wire. This structure was placed across the ditch below the dairy by UVM students working with me. It was, in effect, a biochar dam. Unfortunately, this turned out to be a failed experiment. It captured phosphorus during times of low flow, but it lost it during big rainstorms. Plus, often the water was able to get around the dam or absolutely right over the top of it. So it was ineffective. One activity we have done a few times was to show teachers how to make mini biochar makers out of soup and vegetable cans by punching holes with hammer and nails and can openers. It was a great way to explain to kids how pyrolysis works. The cans were filled 2/3 full with wood pellets, which were lit on the top. Once combustion happened, the wood pellets beneath the flame would heat up, giving off the gases trapped in them. These gases rise to the top of the can, preventing the pellets on top of them from getting oxygen and thereby turning to ash. This was what Rob was describing with the Kontiki. At the top of the can, the gases combust, providing a clean, smokeless flame, perfect for roasting marshmallows, and a definite hit with kids. Once all the pellets are heated and have given up all their gases, the fire is quenched with water. And this is actually another failure in a way, in that the teachers were all excited about this, but they would go home to their principals, and the principal said, "Kids and fire? No way." So it didn't happen in schools, at least not very much. In 2018, I purchased a tractor trailer load of biochar from a charcoal maker in Quebec and unloaded it into our manure lagoons. It spread evenly across the entire surface, forming a cap that completely eliminated the smell. I didn't have a way to measure methane emissions before and after, but I know from scientific literature that they were cut dramatically and that both methane and nitrous oxide emissions were significantly reduced during spreading. This is a close-up of the biochar. You can see that the chunks are significantly smaller than the chunks that were coming out of the retort, but it's not super fine, not dusty at all. This past spring, we added this material to the alleys in one of our freestall barns to see if we could detect a reduction in greenhouse gases. With a device owned by UVM Extension, we monitored CO2, methane, hydrogen sulfide, and ammonia. But this was yet another failed experiment because the barn was too open to the wind to accurately capture the real concentration of gases. In 2018, I went to Austria on a biochar study tour and saw this chicken shed where the birds were being fed a feed pellet containing 2% biochar and no antibiotics. There was very little smell because the biochar captured the ammonia in their manure, and growth rates and mortality were comparable to an identical chicken shed nearby. The farmer was super happy with the results because he could get a higher price for hormone and antibiotic-free meat, which more than paid for the biochar feed. Plus, the nutrients in the manure were stable when spread on his fields, and he was sequestering carbon at the same time. I began this presentation by saying biochar has a big impact in 3 areas: energy, agriculture, and environment. Here's how biochar will impact Shelburne Farms and how it will help us get to drawdown. In the process of making biochar, the excess heat becomes carbon negative once the biochar is in the ground, and it displaces fossil fuel. In the area of agriculture, biochar significantly reduces greenhouse gases coming from manure, specifically the methane and nitrous oxide. Water quality increases because of the nutrient retention capacity of biochar. A company called Vermont Biochar has developed a filter that captures up to 90% of the phosphorus in field runoff and is being funded by the Lake Champlain Basin Program to further develop it this year. Feeding biochar to animals reduces enteric emissions from digestion by 20%. In our case, that 20% translates into about 50 tons of CO2 annually and makes the animals healthier, able to produce more milk and gain weight quicker without reliance on antibiotics. A recent study out of UC Davis that Rob mentioned shows that feeding cows seaweed reduces enteric emissions by a whopping 82%. As Rob pointed out, once in the ground, biochar is a perfect home for nutrients and microbes, as well as a sponge for water, making the soil much more fertile, particularly in drier areas and in areas with depleted soil. In the area of the environment, there's the positive impact on water quality again, and carbon sequestration. And that wraps up my presentation. I will stop my screen sharing and send it back to the moderator.
So any questions from anybody? Because I have questions, but others can go first. And feel free to unmute yourself, turn your videos on as you ask your question. Okay. No, so I'll ask my question. Yep. So Marshall, when you were saying how your open barn, does biochar perchance promote factory farming practices? Like your barn was too airy, or when you feed your animals a certain percentage of the food, but if they're out grazing, that percentage goes all wackadoodle. So could it potentially promote factory farming practices?
Well, it would, you saw that picture of the chicken shed.
Mhm.
That's, that's not nearly as big as some chicken sheds, but there were a lot of birds in there. I think many thousands of birds. And yeah, I guess it would allow you to reduce the impact that those animals have. In our case, I didn't want to interfere with our normal practices. I was just trying to corroborate information that I got from a computer model called Comet that was saying, dairy cows produce X amount of methane. And I wanted to just see if I could monitor how much methane it was actually producing, they were producing. And it really, to do that, I would have had to close up the barn and to the detriment of the animals.
Mhm.
And I wasn't prepared to do that. But obviously, if we have 106 milking cows right now, if I had 2,000 milking cows and that much more manure, et cetera, I would have to have some technology like biochar to reduce the amount of emissions. But still, I'm not a factory farm person.
No,
I
no,
think-
you're not.
Can I jump in here
think
for a
cows
second?
need to be out in pasture.
Can I jump in for a second? In other countries, especially in developing countries, they don't have a lot of outbuildings. And I've seen videos of buckets of biochar being put out in the pasture, and the cows go for it. They like it. They they like to chow down on it. And the other thing is with chickens, all you do is throw some handfuls in the scratch, and they like it too. They see it as beneficial, and so it's you don't have to work hard to get them to take it. The seaweed, on the other hand, they don't like. The seaweed is almost a forced deal. I personally am very cautious about the seaweed for several reasons. One reason is it's really expensive. If you look for it online, you will see just ridiculous prices. And that's because you can't raise it. It's harvested wild. And I'm concerned that, if it becomes something that's popular, that resource would be depleted. The other thing is I've only seen one study on it, and that's not enough. And the last thing is there are additional health benefits to biochar that go well beyond the reduction in enteric emissions. It just makes the cows very healthy. One of the links I'm going to be attaching when I distribute this presentation contains a link to a 40-page article, a peer-reviewed article about the use of biochar in feeding animals, and it's terrific. I would highly recommend scanning at least the beginning and the conclusion of that. I see a question from Rob Kidd about regulations and laws restricting the use of biochar. There are standards. There are no rules restricting it. It's a developing industry right now, Rob, and there is there are standards both in the EU and that have been promulgated by the US Biochar Initiative, which basically state the same thing. They're pretty technical. I can certainly provide a copy of those. And if you follow those, I mean, it speaks in terms of the relationship of nitrogen to carbon, and wants full disclosure on what's in the char. But no, there are no regulations that prohibit it. Now, feed additives need to be approved. It's not a matter of they're restricted. They need to be approved by each state. And we did get approval. One company applied for approval to use biochar in animal feed and received it.
I do have a question. I was wondering what a secondary use would be for the biochar that had been used in the runoff ditch dam that Marshall had been speaking about earlier. You know, the experiment failed. Rob had proposed perhaps screening the runoff through gravel and sand prior to going through the char dam, but I'm wondering what a secondary use would be for the char after it has been, you know, used in the ditch. Would that be suitable for spreading across fields at that point?
Sure.
Yeah, it would, but
Mix it with compost and
probably
it's
mix
good.
it with compost first. Yeah, and it's it accumulates sediment that's in the water, so it is sort of pre-charged with a little bit of phosphorus and some microbes that are in there already, but I put it into compost. And my problem was I needed to design a holding area for storm surges so that there was a constant, steady, lower flow through that filter. And I needed a more sophisticated mix too. There's, since I did that, a lot of studies have been done on the proper mixtures, adding iron to the biomass first.
Pick up the phosphorus.
Yeah.
Yeah, iron. See, remember I mentioned that it has its electrical properties. It's slightly negative charge. We put some iron into the biochar before we pyrolyze it, and it grabs the phosphorus very, very well. 100% removal. 100%. Now, going back to your comment about, we were talking about compost. Biochar helps compost and compost helps biochar. They make each other better. They make the biochar makes the compost better because it adds moisture and regulates the moisture. It absorbs when it's wet and it releases when it's dry. And it also adds aeration. And those are two very, very beneficial things. Plus, it provides habitat for the microbes. I'll bet there are more questions. It must be. Come on. Don't make me talk about carbon offsets.
It's not really a question, but an observation. I'm going back again to the dam across the runoff ditch. It seems like that would be a pretty good solution for problematic farms that have, you know, runoff problems.
Yeah.
And I'm
And tile
wondering,
drains.
Yeah,
drains.
you know, especially since it has a secondary use as well. So I'm wondering if there's any programs out there that kind of push that thinking out.
Well, I mentioned the one that the filter that Vermont Biochar made last year, and they're hopefully perfecting this year with funding from the Lake Basin program. They worked it out so that they say they removed 90% of the phosphorus. And I haven't actually seen the filter and seen how much water they can filter per hour or per day, but it is something that is working, and they actually, I think, got a grant for upwards of a couple $100,000 to perfect it.
Yeah, the key is to keep the pores open so that they can continue to pick up the phosphorus. If they get clogged with mud or silt, it shuts down. One thing I would talk about a little bit is what kind of soil are you sitting on, Marshall? Yeah, do you have Vergennes clay?
We have a lot of Vergennes clay, and we have Palatine, which is a lighter clay.
Yeah.
That's our best soil.
Yeah. Well, Vermont soils are generally, I mean, the predominant type of soil in Vermont is clay. Vergennes clay being the largest type of clay. And clay doesn't handle water very well. It pools, it floods, it erodes. I read a study recently, which is very encouraging. And I mentioned that biochar helps regulate water moisture. This study concluded it was using a biochar made from willow, which we grow in Vergennes, by the way. There's a planting there of something that was intended for biofuels, but there's a coppiced willow plantation down there. But the study concluded that they could increase the soil available water by 20 to 30% by the addition of biochar. Now, if you think about what our weather has been like and what our climate may transition to, moisture regulation is probably going to be a very important aspect of that, and I think this will be a very good tool to look at, and I'd like to do some experiments with respect to that. Very good peer-reviewed studies on that. Could I take a moment and talk a little bit about payments for ecosystem services? How long do we have left?
About 5 minutes. So
5 minutes.
Go with that. I was going to ask a quick question, but
Go
go with
ahead.
that. I think it's an important question. So
Okay.
e-payment
All
for
right.
eco services. Go with that.
Well, this is not going to be for not going to be an individual farmer that makes a little bit of biochar. Although that's not really true. It could be. It could be. There's a new technology that measures soil organic carbon using a probe that's inserted into the ground, guided by a GIS system, so that you can precisely measure soils in the field at specified intervals, so that you can test for all the nutrients that are in the soil and the soil organic carbon, its moisture, etc., without having to send out to a lab. That's a big deal. Now, what that does is, the payment for ecosystem services is not for what you have today, it's what you have after you've made improvements. It measures additionality. Did you do something to actually earn this payment for ecosystem services? That's a very important concept. I want to share something. This is from a company called Puro Earth. They are in Finland. I visited with them a couple of years ago. Fascinating place. This is an auction, and the proceeds from the auction go to whoever owns. Whoever performed the carbon removal gets the money. And in this case, it's probably going to be the farmer. But this is Australian biochar. You're going to learn a lot from this. And this is a carbon offset removal. We're not offsetting anything. We're actually taking carbon out of the atmosphere using photosynthesis, putting it into a permanent form. Its permanence is over 1,000 years in this case. It's been audited by somebody who did an LCA and is willing to sign and seal it. The unit is a metric ton. That's 2,200 pounds. The embedded carbon in this product, can you see that? It says 2.88. That means for every unit of biochar, there are 2.88 units of carbon dioxide equivalent. What you're looking at this 88 euro price is the price for 1 ton of carbon dioxide equivalent. Here's our price on carbon. This is market. This is what's going on. Now, if we had, let's say, I'm gonna make a stretch with this. Let's say we had a co-op among the producers, the farmers, and the foresters, woodlot owners in Vermont, and you could access a $5 million pyrolysis unit that made high quality biochar, and you paid by the hour to use it. And you ended up with biochar. And let's say we took all of the biochar that was produced by farmers using their manure, using their crop residues, using wood chips, whatever they're using, and put it all together and put it on the international market. We would be generating somewhere in this order of $300 a ton for carbon removal. And that does not include the physical carbon. You get to do something else with the carbon, like put it on your soils. This is a path. Most people don't realize that there is a price on carbon, but this is a common one. The going rate for a ton of CO2e is between $100 and $150 a ton, and it's probably going to increase as the situation becomes more serious. Incidentally, Puro Earth was a private company founded in Finland. The NASDAQ just bought a controlling interest in it. This is going to be something which is going to be traded. And it's something which I think represents a long-term source of income for farmers who are willing to produce an ecosystem service. I hope you, are there any questions on that? I'd be happy to answer them. When Microsoft just went out and spent $1 billion on carbon removal, and this was a part of their portfolio. This is one of the only carbon removal technologies which is available today. And it's the only one that's available today at a reasonable cost. It's extremely competitive. The problem now is we don't have enough biochar.
Thank you so much. Rob Marshall, do you have any closing statements? We're at 8 o'clock. Any last words, quick questions, statements from anybody?
No, I really enjoyed this. I really appreciate the opportunity to talk a little bit about it. It's very exciting. Very exciting.
I've enjoyed
thanks
our
for-
conversations. I've loved it. Thank you.
Thanks for having us, and we'll maybe see all of you around somewhere on the farm.
Yeah.
Thank
Keep
you
doing
very
what
much.
you do. Thanks a
Bye,
lot.
everybody.
Okay. Bye-bye.
So thank you very much, Robert and Marshall. And I just want to put a quick plug for our next couple of conversations. June 23rd, we have a conversation about ocean health and the environment. There is an ocean.
About what?
Ocean health.
Uh-huh.
And normally it's not a topic we talk that much about in Vermont, but some could consider Lake Champlain an ocean. I know it was many moons ago.
Inland Sea.
But that's a conversation we're going to be talking. Suzanne, thanks for setting that one up. But also, we have some other in the works that we don't have on our calendar yet, including there's an author who wrote a book about hiking the Long Trail that we're possibly trying to arrange, about the I-89 corridor study, the environmental impacts on medical waste, and somebody just offered to do a conversation about wake boats, about turning up the waters and how much it's pulling up sediment. But as usual, is if you have a topic of suggestion, please email me at rob.kidd@sierraclub.org. We basically host these is to kind of give our members an opportunity to hear other things, other issues that we may not necessarily be working on, such as biochar. I know the Sierra Club position is like a little bit more guarded at this point on it, but because the research is still going on.
There are thousands of papers, Rob. We should
Yep.
talk about that position.
Well, that position's the national organization. We have like there's people in Sierra Club who really support biochar, It's just we, as the national organization, we haven't come up
Yeah.
on a full position on it, but we still wanted to hear it because we know you're doing some great things, innovative programs, and doing things even at Shelburne Farm, that connecting it with the dairy runoff. It's great ideas. So we appreciate having you all on board. And then all of our conversations get posted on our website, normally within 24 hours of this conversation. And our upcoming calendar events gets posted on our website as well. So anybody can go there. So, but thank you, Rob and Marshall and Suzanne for kicking off the event tonight and setting up you two. And thank you for all who joined us tonight.
Thank
Alrighty.
you.
Thank you.
Bye.